Susan DeLue is an occupational hygiene officer at WorkSafeBC. She is a professional engineer with oil and gas industry background. She has experience in failure analysis, risk management, occupational health and safety education, and enforcement. More recently, in her position as an occupational hygienist officer at WorkSafeBC, she has been assigned to work with the Risk Analysis Unit, conducting research and analysis on emerging risks that employers may be unaware of or that are difficult to detect. She enjoys working with employers in an educational way to aid in the understanding of how to keep workers healthy and safe. And Andrew McSherry is an occupational health hygiene officer with WorkSafeBC. Since 2018, Andrew has been one of the officers assigned to WorkSafeBC's Process Safety Initiative. In addition, Andrew is currently assigned to the WorkSafeBC's Risk Analysis Unit, RAU, and has been assigned to there for multiple projects, including ammonia, chlorine, explosives, and paint manufacturing. Andrew graduated with a master's degree of science from the University of British Columbia and is a certified industrial hygienist and a Canadian registered safety profession. The session goes to 2:45, but we'll stop about 5 minutes before the end of the session for Q&As. So thank you, and help me welcome our two guests.
We'll just pretend we can hear the clapping. Wave. Is it okay for me to go? I guess so.
Go for it.
Hi there. Greetings from Vancouver Island. My name is Susan DeLue, and I am a prevention officer with WorkSafeBC, as was told in the introduction. And my colleague that is with me is Andrew McSherry. Today, we're going to be presenting on toxic process gases, managing risk, and meeting compliance. For those that might not be familiar with WorkSafeBC, some people know that they're the books that you have to go to if you've sadly hurt yourself on the job or if family member's been fatally injured. But there's the prevention side of it that Andrew and I work on. And as prevention officers, we regularly go into workplaces to conduct inspections to ensure that employers are meeting the minimum requirements of the health and safety regulations and the Workers' Compensation Act. What that does is hopefully make it a safe workplace for you to be in. Thank you for your time today. So first off is our agenda. Today we're going to be talking about toxic process gases. I might say gases or TPG, just because the other is a bit of a mouthful, used in water and wastewater treatment. We'll talk about the similar characteristics they have, WorkSafeBC's TPG initiative, prevention and mitigation, the basic minimums, and then are your controls reliable? That'll be a little bit of a takeaway that you can use when you go back to work. So what are toxic process gases? The definition, I'm just going to read it. The definition is that they meet the hazardous products regulation health hazard class acute toxicity categories 1, 2, and 3. You don't need to remember that. What you can just remember is that the ones that are typically used in water and wastewater treatment are anhydrous ammonia, chlorine gas, ozone, sulfur dioxide, and chlorine dioxide. So the gases have similar characteristics, as previously mentioned. They're used in water and wastewater treatment and possibly in water distribution. They dissolve in water, and they have low occupational exposure limits. If you're not familiar with the term exposure limit, again, sorry, I have to read these because I don't memorize them. The exposure limit represents the maximum airborne concentration of a toxic substance to which a worker could be exposed over a period of time without suffering any adverse health reactions. That's kind of the key part. There's 3 types of exposure limits that we typically look at. There's the time-weighted average, or the TWA. That is the exposure that a worker may be, that's the concentration that a worker may be exposed to in an 8-hour day, typically a 40-hour work week, that would not be expected to result in adverse health effects. Then there's the short-term exposure limit, sometimes referred to as the STEL. It's the concentration that a worker would not be exposed to more than 15 minutes at a time, 4 times during their shift, with 60 minutes in between. Lastly, there's the ceiling. So this is the the concentration that should never be exceeded during any part of the worker's exposure. Workers should never be exposed to anything that exceeds that concentration. So the other thing that they have in common is they have something called an IDLH. That is the immediately dangerous to life and health value. So immediately dangerous to life and health is an atmosphere containing a substance at a concentration which is immediately dangerous to life and health because the concentration is greater than that from which one could escape without any escape impairing symptoms or irreversible health effects. This also includes an atmosphere of an unknown concentration that may be immediately dangerous to life and health. In other words, even at low concentrations, this is super nasty stuff that if you breathed it in, you likely wouldn't get out alive or you wouldn't get out without irreversible damage. I would call death irreversible damage. To go into such an atmosphere would require supplied air. So there's different IDLH values for each of the gases. Reference you could use is the NIOSH pocket guide or table to look up what those limits are. Another characteristic is that almost all are corrosive to skin, eyes, and respiratory tract, and they can be released suddenly in high concentrations. And at these high concentrations, they're very hard to control. They may put workers at risk, but they also may put the community or neighboring businesses at risk. An example of this would be the ammonia release that occurred in the Fernie ice rink. They were under about 7 days worth of a state of emergency, and neighboring residents and businesses had to be evacuated for over 6 days. And sadly, of course, we lost 3 workers in that incident.
Just for perspective, that only amounted to 9 pounds of ammonia that actually was released that killed 3 workers. The exposure limit and IDLH for things like chlorine are actually lower, which means you need even less to kill somebody.
So one of the things that we have going on at WorkSafeBC is the WorkSafeBC TPG initiative for water and wastewater. It is being spearheaded by the Risk Analysis Group. And the Risk Analysis Group is a group within WorkSafeBC that it contains risk industry specialists, as well as prevention officers like Andrew and myself. What they do is they look for risks that employer may be unaware of or risks that may be difficult to detect. They use information that's gathered not only from incidents that occur within British Columbia and Canada, but also globally. The focus for toxic process gases is actually high consequence risks. And what we want to determine with this initiative is whether or not employers are knowledgeable about the hazards, they're knowledgeable about the risks and threats, and if they can demonstrate that they've implemented controls to prevent or mitigate an unwanted event. There is an inspection that's coming up. There's actually been a couple of inspections that have already happened with a couple water treatment plants where we've gone out and we've conducted inspections part of the initiative. And we'll be doing that with other water and wastewater treatment plants. So we might be coming to a plant near you. WorkSafeBC is in the process of developing a tool that should help you should we be coming to your facility, but also if we aren't coming to your facility. It's a self-audit tool that will contain some checklists to help you evaluate how well you know the hazard, how well you know about the threats and the risks, and as well whether or not you've identified the appropriate controls. So the big part of the initiative is looking at the employer's ownership of risk, and they're demonstrating that ownership. So there's 3 parts to demonstrating that. There's the knowledge of the hazard, knowledge of threats and applicable controls, and implementation of adequate, reliable controls. So knowledge of the hazard looks at whether or not they're knowledgeable about the health and physical hazards to workers, such as corrosion to the skin, eyes, respiratory system. It's also knowing about the types of incidents that could lead to an unplanned event or release. And also it's about looking at the potential consequences should an incident occur. Knowledge of the threats and applicable controls looks at what are the threats that could result in an unplanned event. What controls have been initiated to both preventative and mitigative to eliminate or reduce the likelihood or reduce the consequence, of that event from happening. And lastly, with the implementation of controls, we want to make sure that those controls are adequate, reliable, and durable. So an adequate control would be one that is the right tool for the job. It's one that's been designed to do that task. For a reliable control is one that's actually going to function when it's needed. And in the case of the emergency, WorkSafeBC has investigated a lot of incidents where automatic shut-off valve or an emergency shutdown device has not functioned at the time because it's never been looked at. Nobody's ever tested it. So they didn't determine whether or not it would be reliable when it actually was needed. A durable control is one that will stand the test of time. So there's integrity to that control. And it might be knowledgeable about being when you need to switch that control out so it's still durable, because most controls do have a lifetime. So when we look at managing risks, there's two ways to go about it. There's prevention and there's mitigation. So prevention is looking at preventing an event or an unwanted event from occurring. The mitigation side, I'm going to leave for Andrew to give you examples and talk you through. So what can go wrong? Toxic release, fire, explosion. These are things that you want to look at with the toxic process gas that you're handling. Then there's knowledge about why and how things can go wrong. So we want to know what could fail, what could break, what could be opened incorrectly, things like that. What would result in, or what action could happen that would result in an unwanted event? Why would it happen? Is there corrosion? Is there incorrect instructions or the wrong tool, the wrong valve being in place? Then lastly, we want to look at how to prevent things from going wrong. There's a few things that we can look at. One example would be maintenance of your equipment. So is there a maintenance schedule for one? Have we identified what equipment needs to be maintained? Have we looked at the frequency with which that needs to be maintained? So has anybody taken a look at the manufacturer's instructions, for instance, and to determine that, or maybe even industry standards to determine how often things need to be maintained to make sure that they are reliable and durable? Is anybody taking a look at whether or not that's actually being done? So it's great if you've got a schedule and you've set frequencies, but if this task isn't being done, and it's not through people not doing the work, but maybe there's a budgetary constraints, then we need to make sure that everything's being done as per the schedule. Integrity management is similar to maintenance. So with integrity management, do we have a list of equipment that needs to be inspected? Is it going to be a visual inspection or maybe a non-destructive testing type inspection that would look at things like corrosion, for instance? Is there a schedule of when you need to do these inspections, what pieces of equipment need to be inspected and when? Again, sometimes this comes from equipment instructions, and other times this might be coming from industry standards as to when to do it. So who's making sure, who has ownership of that inspection happening? Who's making sure that it's actually taking place and it's taking place within a timely manner? Another thing that I want to speak to with regards to prevention is procedures. So there could be procedures for storage, handling, and use of cylinders, or procedures for the connection and disconnecting cylinders, for instance, things like that. Procedures are actually extremely important, but often overlooked. One of the things with procedures is you want to see, A, do you have them? And also, are they clear and descriptive? Do they list a set of task-specific steps? And who's developing these procedures? So is the person developing the procedures somebody that doesn't actually take on the task? Because if that is the case, they might be inserting or not including information that's required. At the same time, are the procedures being written by an operator, for instance? So operators, very knowledgeable on the job, but in order to write procedures, there's the chance that they'll actually skip some steps because it's very intuitive to them. So you actually want to have a couple people involved in writing them. The other thing is with procedures, are they clear? Could a person with very little experience follow the procedures and basically go through the task and understand what steps need to be taken? This is really actually more important than people think, because if you don't have clear procedures, in the event of an emergency, these procedures sometimes are going to be your guiding light to keep you focused on what you need to do and all the steps. And in the case of emergency, when there's adrenaline going on and there's fear going on, it would be really easy to miss a step if you're just going by memory, right? Or should something happen to the person that knows all these steps and somebody else has to take action, they may not know these steps either. So it's very important to have clear, concise steps. Another thing is that they're very accurate. So you want to make sure that the procedures don't say to turn valve A clockwise, because what if there is no valve A? So if nobody's vetted through these procedures, then somebody might take a look at these and just kind of ignore them and say, well, that doesn't make sense, and then not follow through. And then in the event of an emergency, you'll have somebody running around looking for valve A when there's no valve A, because nobody's taken a look at these procedures to see if they're accurate. So that's a little bit on prevention in managing risks. And now I'm going to pass it over to Andrew. He'll talk about mitigation. I'm the one that's actually controlling the slide, so forgive me if I skip ahead. I will get back on the slide as required.
So before we start talking about mitigation, I want to talk about a little bit about the difference. Obviously, preventing is about keeping some materially unwanted event from happening. In our case, our biggest concern with a toxic process gas is a loss of containment event, which would certainly put the people inside dealing with the toxic process gas at risk, but it could also be a community risk. That's certainly the ideal to keep something from happening in the first place. Much of the regulation that pertains to the toxic process gas under WorkSafeBC's requirements actually provide prescribed requirements relating to mitigations. So in the event that something actually does happen, having in place provisions to minimize the harm if something actually happens. So keep in mind, both things are important. Both the prevention and the mitigation is important. There are the more prescribed requirements, and if you have been inspected by WorkSafeBC in the past, without a doubt, much of the focus may have been on mitigations in the past. We want to be clear that as part of our initiative and moving forward, we want to balance that out a bit so that we are dealing with both that prevention side as well as the mitigation side. Again, you can't deal with one or just the other. Really need to have both sets addressed. So mitigations. To start off with, I'm going to talk about some engineering types of controls that are prescribed by the regulation, and that starts off with having enclosures. So the whole principle is that your toxic process gas or gases, you're going to want to contain them within rooms so that if you do have a loss of containment event, you're limiting the spread. In conjunction with that, obviously your enclosures, you're going to want to restrict access to operators who are properly trained, properly protected. You're going to want to have monitors and a capability of detecting the concentration inside the enclosure before you actually go in it to ensure that it's actually safe to enter. In addition to that, these enclosures are required to have ventilation so that you don't get too high of a concentration inside the room, and so that you can safely reduce the concentration if things actually do go wrong. Next slide. So a little bit of additional detail about ventilation and maybe some flags for you to think about from your own operation. It starts with ventilation design. So one key characteristic that that any of these ventilation systems should have for these toxic process gas enclosures is proper stack height. So regardless of whether it's heavier than air or lighter than air, you're going to want to have a stack that's actually going above your building at a designed height that's been designed in accordance with calculations or modeling, so that you get proper dispersion from the area. Again, the whole principle is if you do get something go wrong, you want to get the contaminant out of that area so that you can safely do whatever work you need to do inside your enclosure. In addition to that, intakes are also of concern. Now, for most of the water/wastewater treatment sites that I've seen, generally speaking, they intake from the outdoors, and so you're not going to necessarily potentially gas someone in an enclosed space, but that is certainly a consideration if you do have that potential for ventilation failing and for the toxic process gas to actually escape via your intake. Then you need to ensure that you have dampers to keep that from actually happening. Now, I just mentioned about ventilation systems failing, and obviously that's a possibility. And there is actually a requirement under the regulation that specifies about monitoring your ventilation system. So monitoring the functionality of your fans, your fan motors, your airflow, so that if you do actually have something happen, that your workers are made aware of that and can respond, because obviously not having that ventilation system is a significant concern if something goes wrong. So that monitoring can be in multiple forms. It could be in the form of electronic devices linked to your ventilation system that notify operators if something's gone amiss. Potentially, it could be regular verification by operators in an effective way to verify that the ventilation is working fine. One way or the other, you want to make sure that you've got an effective system to make sure that your ventilation is working properly should something go wrong. In addition to that, you want to locate your extractor fans outside of the building. So rather than inside the room or enclosures, you want to have them outside, and that's to ensure that you've got effective negative air within that room. Next slide. So some other key mitigations, and this is an issue that when we were looking at the pools as part of a prior initiative, we were seeing to be a fairly common concern, and that was a lack of a shutdown device to stop a release if you had a loss containment event. So when we're talking about that, if we're talking about an ozonation system, we're talking about something that you can, through an alarm or through remote from outside the enclosure, press or activate, and that will stop ozone generation from happening. If we're talking about something where you've got a quantity of toxic process gas stored in some medium, whether it's a tonner or whether it's a cylinder, we're talking about something that's going to be attached to the valve on that container, and that will close down that valve should you get an unwanted event there. Whether it's a remote button that you can activate, or whether it's the alarm causes the control system to close down the valve. Ultimately, you're causing isolation there, and you're hopefully actually going to bring that emergency, relatively speaking, under control just through that one device, and avoiding having to send people in SCBAs. So one other requirement that's an engineering control requirement is relating to pressure relief valves. So not all of your systems will have pressure relief devices necessarily, but those that do need to ensure that the pressure relief device exhausts to the outdoors. So having that discharge into the room is a problem, right? If you were to actually get pressure relief into the room while a worker was there, that would be quite dire. So in addition to having these things discharged to the outdoors, these pressure relief devices discharged to the outdoors, you also want to have some effective system to notify your operators if your pressure relief is activating, whether due to overpressure or because the pressure relief device has failed open. So There are devices on the market. I'm certainly well aware of them for ammonia refrigeration systems, as an example, where they actually monitor what's coming out of your pressure relief device. For other types of things, you'll want to take a look at what's out there and have some effective system to ensure that operators are promptly notified. Next slide. The last line of defense as it relates to mitigation, after we've tried to address things through our engineering controls and our administrative controls, which we'll get into in subsequent slides, is your personal protective equipment. So anytime you're going into a space where you could potentially get a loss of containment event of these toxic process gases, it's important to be carrying or actually wearing an escape respirator. And if you're performing any tasks that could potentially change the risk profile and increase that risk of a potential loss of containment, such as through or of exposure for that matter, such as through doing things like maintenance, changing cylinders, or even investigating a leak, then you actually need to wear a respirator as per the regulation. Next slide. So one other type of mitigation that is important to have is to address the thing that we haven't talked about so far really up to now, and that is we've been focusing on inhalation exposure, but all these gases typically have a nasty impact on your skin as well as your eyes. And so certainly what you want to be able to do is to flush them should that exposure take place. So a key thing is to ensure that, number one, that these emergency washing facilities are as close as possible to where that exposure could occur. So generally speaking, these are located immediately outside of the enclosure. And the reason for that is obviously if you had an incident and these facilities were inside the enclosure, the facilities wouldn't be very useful to you. These facilities also need to be designed with warm tempered water designed to provide flow for 15 minutes because we expect that there would be an amount of time needed to actually flush. It's not going to be something you can flush right away, all the way out. And keep in mind that if you do have these facilities located outdoors, regardless of whether you're in northern BC or on the south coast, you need to factor in freeze protection. So as an example, heat tracing to prevent your lines from freezing up. Next slide. So putting all those mitigations together, here's a diagram from WorkSafeBC's chlorine publication, but they show a few examples of these mitigations that we've talked about. The ventilation, the chlorine sensor in conjunction with a control system linked to an alarm, as well as the emergency shutdown and the automatic closers that would actually close the valves on your cylinders. So it's a whole group of different controls involved to effectively mitigate the risk. But again, this is about harm reduction. We want to do this, but as Susan discussed, we want to also keep our focus on preventing these things from happening in the first place too. Next slide. So layering on with these controls that we've talked about, both the mitigation and the prevention side, are a few program requirements, and they're called an exposure control plan and an emergency plan. So let's start talking about the exposure control plan. So for simplicity's sake, let's think of the exposure control plan as the reference program document that workers are going to rely upon in normal conditions. So in other words, when you don't have an emergency taking place. There are some fundamental elements to an exposure control plan that need to be addressed, starting with assignment of responsibilities. So you're going to have somebody who's going to ensure that this program's actually taking place. That could be supervisors, that could be a manager. You're also going to have workers who are going to be responsible for carrying out what's discussed in this exposure control plan. Now, once you've figured that part out, it's a matter of getting into characterizing the risk. So what are your toxic process gases involved? Keep in mind that you can have an exposure control plan that addresses just one substance, but if you have multiple toxic process gases at your site, you can certainly use a single exposure control plan to address those various hazards with the variations in dealing with the different hazards sussed out. So now you know what your substances are. It's time to do an assessment. So what's key is to characterize what people are doing and how they might be adversely impacted through doing their work. So who's doing the work? What are they actually doing? And what's the exposure when they're actually doing that work? And again, keep in mind that this is when normal things are happening. There are going to be exposures when people are doing their normal tasks. Based on what's actually going on and your risk profile, then you need to then identify what are the appropriate controls to effectively minimize the hazard to the workers. Keeping in mind that there's not only the controls from the standpoint of that immediate activity, but there's also the consideration that the worst could always happen and you could have something come out. With the controls identified, the next step is to actually develop the written work procedures to actually explain how workers are going to effectively implement their controls so that they're going to be protected for the duration that they're doing their activity. So whether that's going into the room to do a visual check, whether that's changing out a cylinder so that you can put on a new cylinder because something's gone empty, or whether that's doing some sort of maintenance activity, any of those has a potential for exposure. So how are you going to effectively protect the workers? Now, building upon those procedures, you need to have an education and training component. So awareness of the hazards, but also the effective training to ensure that workers will competently carry out those procedures that are developed. And of course, supporting that are records showing that whatever verification and whatever training that has taken place to ensure that the exposure control plan has been implemented are actually happening. Now, on an annual review, this exposure control plan needs to be reviewed in conjunction with your health and safety committee, and that's to verify that, number one, this exposure control plan is being implemented, but number two, to identify if there's any changes that may necessitate changes to your exposure control plans, as well as to identify opportunities for improvement, because the profile of your risk may change. What is known about how to effectively control the risk may change, or you may uncover something in the course of doing the review that may indicate to you that there's a risk there that needs to be better controlled. Next slide. Of course, the other side of things from a program perspective is the emergency side. And the emergency plan is a key thing that needs to be in place. The last thing you want to do is to have an emergency and to be trying to think out what you're going to do and how you're going to handle that in the heat of the moment. That's when people can get potentially hurt. So an emergency plan starts with identifying what you actually have, what quantities you have, and to identify where they are. From there, that's where you do your risk assessment and identify, well, what can happen? So in the case of these toxic process gases that we've discussed, I've mentioned that a loss of containment type of event is certainly a major cause of concern. But another thing to consider is, at least in the case of ammonia, is that it is a flammable gas. So you can have a fire explosion event also take place with respect to ammonia. So those are some examples of things that can happen. And the next step is to think creatively. What can actually cause those unwanted events to happen, right? So as an example, you could have a pipe that could suddenly lose containment. You could have a seal failure. You could have some sort of event that could cause your cylinders to overheat and the valves to open up. There's any number of things, but the important thing to do is to think of, in your particular context, what are those things that could lead to loss of containment? I would suggest that in the course of thinking about that, to take a look at any information that you can obtain from your manufacturers, as well as the available standards bodies. For those who have chlorine, consider the information from the Chlorine Institute as a resource for information as well. Because ultimately, the broader that you can get a source of information about what could cause risks to happen, the more you're going to be able to prepare and implement controls. So now that you've identified what could go wrong and why that could happen, it's a matter of then layering on how you're going to effectively prevent that and mitigate that as well. And you want to think about that not only from the standpoint of within your site, but potentially if it applies beyond the fence line as well, because your people on site may be well prepared, but is that necessarily going to be the case for the campground that's a few acres or 100 meters away, as an example? So consider what the consequences would be if something actually did happen. What would that actually look like? So now that you've done the risk assessment, it's a matter of then figuring out how you're going to go about carrying out your procedures should things go wrong. So it starts with identifying what are going to be your criteria to notify people to evacuate, and then what are people going to do in the form of evacuation? How are your people going to go about trying to bring this situation under control? Maybe in some cases you're presently not equipped to be able to do that, and perhaps that is going to cause you to think about revising your risk assessment and looking at your controls. But ultimately, it's about a matter of thinking through and identifying what are the things at play and how you're going to effectively get people out of harm's way and bring the situation to a safe condition. Again, just like within exposure control plan, the next step is then to layer on your training. So making sure that people know what to do and layering on the drills to not only test that those procedures are effective and make sense, but also that the people your people are competent at that. One area that we've noticed with a lot of employers as it relates to emergency plans is they typically often do evacuation drills quite often, but we've come across a number of them that have neglected to do drills that relate to the response to actually bring the situation under control. And so it's not really clear when we encounter those employers how their response is going to actually work in practice. Just like with an exposure control plan, there is also an annual review component in conjunction with your health and safety committee. And again, that's to look at the implementation of your emergency plan, as well as to look at opportunities for improvement and whether things have changed since your last review. Next slide. So now that we've talked about your controls, both on the preventative and mitigative side, we've talked about program elements. It's time to talk about ensuring that your controls are reliable, because ultimately you don't want this. This is an incident involving chlorine. It wasn't a wastewater site, but ultimately it was a loss of containment event. And unfortunately, the learnings from this was that the means that the employer used to verify their controls wasn't effective. In this case, a hose burst, and that being one problem. And another problem was that their automatic shutdown devices, which were installed, failed to work fully. So as a result, they had a loss of containment event of chlorine forming a large cloud that went on for hours. certainly what any employer should want to be in a position to be in is to be able to, when WorkSafeBC comes for an inspection or at any other point in time, be able to confidently know that their controls, which they've put in place, whether it's a $5,000 control, $20,000 control, or $100,000 control, is actually going to work when needed. Because what's the point of having a control if it's just there and and you have no idea if it's going to work or not? Next slide. So there are a number of controls that need to be thought of, both on the prevention and mitigation side, from the standpoint of verifying whether they're reliable. And it starts with whatever is actually containing your toxic process gas. Obviously, if any of those things fail, whether it's valves or piping or cylinders or any other piece of equipment, then you've got an emergency on your hands. So how do you ensure that those things do not get run to failure, or you don't have a condition that causes them to fail? Key thing. Another consideration is your control systems. So just because you have this sophisticated electronic system doesn't necessarily mean that it's going to work properly. So what testing have you done to verify that whatever stimulus that causes your control system to do something else is actually designed properly? How do you know that if you hit the X set point, that consequence Y of shutting down a cylinder actually takes place, as an example? That's a matter of doing testing, not only when this is first commissioned, but you also want to think about doing that on a periodic basis of verifying everything's still working together. In addition to that, everything that's interconnected with the control system or every other type of critical device also needs to be thought about. So whether we're talking about a monitor, we're talking about some shutdown device or pressure relief device, or whether it's an alarm, all of those can potentially fail. So how do you know that those things are actually working properly? Ventilation, as we discussed, as I discussed earlier, there are requirements that are prescriptive in the regulation that call for monitoring of these, whether it's the fan, the fan motor, or the flow rate. All of those need to be monitored for, and operators need to be made aware of if there's something going wrong with them. As Susan made reference to previously, procedures are something that you need to verify. So just because you have procedures doesn't necessarily mean that people are going to follow them 100%. And I think it would be a fallacy to think that under 100% of the time, you're going to get procedures 100% implemented. All you can do, though, is to ensure that people are as knowledgeable as they are, and you've got effective verification to ensure that those procedures are actually taking place. So the question that I would suggest each of your workplaces do is verify, well, what are our procedures, and are we actually doing what these procedures do? Do they align? If not, then that should lead to further questions. And then next up is PPE. So obviously the PPE is a last line of defense, but ultimately that could save somebody's life. We certainly don't want to rely on that as the primary means of control, but it certainly may need to be relied upon. So are people clean shaven so that their respirators are actually going to properly seal with them should they get an exposure? Are people actually fit tested? Are the cartridges or consumables that workers use still good? Have they not expired? So there are things to verify to ensure that even the PPE is going to be reliable if and when the time comes. Next slide.
Guys, your time is almost up.
Sorry?
Your time is basically up, so if you could just wrap it up, that would be great.
Okay.
Yeah.
So the key thing to do is to ensure that you're able to verify that things work, know why that type of verification is needed, who's qualified, and in particular, how often. So be able to show to WorkSafeBC, if we're doing an inspection, how you arrived at doing your verification to ensure that your control is reliable. Next slide. And obviously, ensure that you have supporting records and have a clear assigned accountability system. So who's actually verifying that there are actually records and things are actually done? It's more than just an operator doing a certain check. There needs to be some layer of oversight to ensure that all that stuff is actually happening. Questions?
Great. Well, thanks so much, Andrew and Susan. Unfortunately, out of time. We do have some questions, so if it's all right, we will forward those to you. And if you could just respond directly to those questions, I really, really appreciate it. But thank you for your presentation. A lot of information there, and very thorough, which is obviously apropos for the issue that you're dealing with, which is potentially quite a dangerous one. So thanks very much, guys, and appreciate that. Cheers.
Thank you.
Thanks.